In this tutorial, I'm going to show you how to prepare an input file for an RFC run. So we're going to be doing a run that's recharge and some fractional crystallization. Go ahead and navigate again to your Documents folder, open up the MCS folder, and we're going to go to our Input and Output folder. And you're going to select the file called MES_R2FC. Go ahead and open that. And again, the first thing you'll notice is we do have our system variables here. We do not want to have assimilation occur, so we're going to set our FM0 to 1. We don't necessarily need to exclude any phases, so we're going to leave that blank. Our pressure is going to be set at 2 kilobars. Enthalpy convergence steps at 30. And our oxygen fugacity is going to be run at absent, so FO2 equals none. For my magma composition, I've got a basalt in here. Now I have normalized it to 100 using the little doodad over in columns F and G. My starting temperature for my basalt composition is 1300 degrees. I'm setting my temperature decrement at 10 degrees. And because I'm not really interested in things that are happening at lower temperatures, I'm actually going to do a hard stop at 850. So this simulation will stop when the magma temperature reaches 850 degrees. Next, we're going to look at the Wallrock parameters. So the Wallrock parameters here, again, I have a more mafic basalt. I do want to switch off assimilation, so by making my Wallrock composition even more mafic and hotter than my magma composition, it's never going to happen. The end temperature for my Wallrock is set at 850 degrees. So this is a temperature below the solidus. In fact, I'm going to change this to 800 degrees just to make it a little bit lower. The temperature decrement for my Wallrock composition is set at 25 to make sure the Wallrock prime operation goes pretty quickly. My starting temperature for the Wallrock is going to be 1100 degrees, just above the liquidus. And my initial Wallrock mass is set at 1,000 grams. So this is 10 times what the magma system is set at. Remember, the magma system is automatically set at 100 grams. So by making sure that the Wallrock's mass is larger than the magma mass, again, it's just another way to turn assimilation off. Additionally, my starting temperature for my Wallrock during the actual modeling run is going to be set low at 400 degrees. All right, to the recharge. So the first thing you'll notice here is this box that says recharge trigger mode. There's two ways to trigger a recharge event during a magma chamber simulator run. The first is by delta, and the second is by temp. So say I want to set this by temp. I need to type in by temp in this cell. Now you'll notice that by is lowercase, and temp, the T has been capitalized. Likewise, for by delta, the by is lowercase and the D in delta is capitalized. This is case sensitive. If you don't have the correct capitalization, the magma chamber simulator won't recognize what to do and it will not work. For the composition of my recharge here, I have it set just as a dacitic composition. It's reasonably hydrous. I'm only going to input, though, 10 grams of this dacite into my magma composition. So the mass of the recharge is very, very low. You can actually make this whatever you want. If you wanted to influx just an enormous amount of recharge into the magma composition, you could say set this at, 900 or even 1,000. It's whatever you need to do for your modeling run. For this, I actually set mine at 10. The next parameter is the recharge temperature. This is actually the temperature of the recharge composition at the time it mixes with the magma composition. So in this case, I have it set at 800 degrees. Conceptually, the way you would think about this is that I have a basalt that is at whatever degrees, 1,000 degrees or so, and I'm going to be mixing it with 10 units of an 800 degree dacite. The next parameter is the recharge trigger temperature. So this is the temperature of the magma composition when recharge is triggered. To clarify that conceptualism, you can say, okay, now I have a basalt that is at 1025 degrees and I have 100 units of it, and I'm going to be mixing it with 10 units of an 800 degree dacite. The next box you're going to leave blank because we're triggering the recharge by temperature. If you were to do recharge by delta, what you would do is back up here in the first light blue box, type in by delta. And then here, under temperatures and mass, we'd leave the trigger temperature blank, and we'd put some number in for the delta trigger temperature. The way that recharging by delta works is it says, okay, well, our liquidus temperature might be at 1100 degrees for the magma subsystem. And let's say I want to set my by delta at 50. So the magma composition will actually cool 50 degrees, and then after 50 degrees of cooling, the recharge will initiate. If I were to set this to 100 degrees, the recharge event would trigger after 100 degrees of cooling. It really just depends on what you're modeling as to which way you'd like to set the temperature. I've done both, and there's different upsides and downsides to both. If you do by temp, you know exactly when the recharge event is going to hit, especially if you're doing multiple recharge events. If you do by delta, you know approximately when the first recharge event will hit, but after the first recharge event, your magma and recharge completely hybridize, and you have a new hybridized magma composition along with a new hybridized magma temperature. Then the second recharge event, if you do by delta, would be triggered, say 50 or 100 degrees of cooling after the new hybridized temperature. The magma chamber simulator can handle up to 5 different recharge events at once in one model. So if you would like to have more than one recharge event happen, you would just scroll down and you would input whatever parameters you would like for recharge events 2, 3, 4, and 5. For this simulation that we're filling out the input file for, this is actually an R2 FC run. So we have 2 recharge events and fractional crystallization. The second recharge event is going to be triggered when the magma composition reaches 975 degrees. So we're doing again by temperature. Now it's also important to note that you can either do by delta or by temp. So if you do 4 recharge events, all 4 have to be triggered either by delta or by temp. You can't mix and match. It's a one or the other sort of situation. If you only want 2 recharge events, like we do in this case, we can scroll down to recharge event 3, and you'll see I have the pre-populated, pretty mafic basalt composition in here because I'm not doing a 3rd recharge event. And I've also completely cleared out cells B140 through B143. And this ensures that there's no 3rd recharge event. I've done the same thing for recharge event 4 and recharge event 5. So for this simulation, we're restricted to 2 different recharge events. So that concludes this tutorial on how to complete an input file for an RFC run. In our next tutorial, we're actually going to go through how to use the magma chamber simulator to perform a simulation.